For 8 unbroken years, 400,000 pages of classified American diplomatic cables were silently harvested before they ever left the typewriter. The cryptography was never breached, the cipher machines were never touched. The radio rooms were secure. 13 IBM Selectric typewriters inside the United States Embassy in Moscow had been compromised at the factory. A Soviet-built sensor was hidden inside the comb support bar, a structural metal beam underneath the keyboard. Every keystroke was logged. Every day, a single sub-second radio burst carried the harvest to an apartment 3 blocks away. The most sophisticated hardware implant of the Cold War was a structural component nobody thought to inspect. This is File 18, the bug inside the bar. The tip arrived at Fort Meade in March of 1984. A French intelligence officer briefed his NSA counterpart. A Soviet defector being processed by French DST had mentioned, in passing, during debriefing, that Soviet intelligence had been reading typed traffic from the United States Embassy in Moscow for many years. There were no specifics, there was no mechanism, there was no corroboration. The tip was, on its face, almost certainly a Soviet disinformation operation, designed to make American counterintelligence officers distrust their own embassy hardware. But Walter Deeley, the deputy director of NSA Communications Security, could not afford to assume that. Deeley initiated what became known internally as Project Gunman. Within 72 hours, every electric typewriter at the United States Embassy in Moscow and at the consulate in Leningrad, 16 IBM Selectric typewriters in total, was packed into oversized diplomatic pouch crates, sealed under top-secret classification, and flown to Fort Meade aboard a U.S. Air Force C-141 transport. The embassy reverted to manual Royal typewriters for classified work during the audit. Ambassador Hartman gave the order in person. The typing pool went silent. At Fort Meade, the 16 Selectrics were placed in the NSA Hardware Disassembly Lab. A long line of workstations, each with a typewriter under a fluorescent overhead lamp. Walter Deeley addressed the assembled disassembly team, 20 NSA hardware engineers in white lab coats, and gave them their charge in plain English. Take every machine apart down to the last component. X-ray every component. Log every variation from baseline IBM specifications. Find what is wrong or prove that nothing is. An IBM Selectric typewriter contains approximately 12,000 individual components. 16 typewriters meant approximately 192,000 individual components. The largest hardware audit in NSA history was about to begin. For 5.5 weeks, the disassembly team found absolutely nothing. Component after component matched the IBM baseline specification. X-ray after X-ray showed normal internal structure. The audit was running through 134,000 components without a single anomaly. Walter Deeley was beginning to consider that the French tip had indeed been Soviet disinformation, and that the United States had just disrupted classified typing operations at its most important diplomatic post for nothing. And then, in the middle of the 6th week, an engineer dismantled the comb support bar of a Selectric from the Moscow embassy. The comb support bar is the structural metal beam that runs the full width of the typewriter underneath the keyboard. Its function is purely mechanical. It provides rigid support to the keyboard frame so that the typing element ball can strike paper with consistent force. In the IBM baseline specification, it is solid metal. It contains no electronics. It is one of the most boring components in the machine. On the Selectric the engineer was dismantling, the comb support bar was hollow. Inside the cavity, packed against the inner walls of the bar, sat approximately 80 miniature electronic components. A magnetometer-grade Hall-effect sensor, a solid-state memory chip, a miniature burst-mode RF transmitter, a coiled antenna wire, a battery pack rated for 10 years of standby power, The functional flow, when the team reconstructed it, was elegantly simple. Every time a typist struck a key, the IBM Selectric's typing element rotated to one of 88 discrete angular positions. Before striking paper, each angle produced a different character. The Hall effect sensor in the bar read the ball's magnetic field orientation at the moment of strike. Each angle was a unique magnetic signature. The sensor logged every keystroke into the solid-state memory chip. Once a day, when the typewriter had been idle for at least 30 minutes, the bug ran a compression routine on the keystroke log and transmitted the compressed log as a single sub-second RF burst at 33 MHz to a Soviet listening post in an apartment 3 blocks from the embassy. The burst was too short, too narrow, and too low power to be detected by routine RF counter-surveillance sweeps. The team systematically dismantled the comb support bars on every other Selectric in the audit. Of the 16 typewriters, 13 contained the same Soviet-modified comb support bar. For approximately 8 years, 13 IBM Selectric typewriters at the United States Embassy in Moscow and at the consulate in Leningrad had been silently logging every keystroke of every classified document typed in those buildings and bursting the compressed logs to Soviet operators on a daily schedule. The bug operated by NSA's eventual reconstruction from approximately 1976 until the typewriters were pulled from the embassy in April of 1984. 8 years. During those 8 years, the United States Embassy in Moscow handled the entirety of U.S.-Soviet diplomatic traffic. At its most strategic moments. SALT II negotiations. The American response to the December 1979 Soviet invasion of Afghanistan. The Reagan administration's arms control posture. The Strategic Defense Initiative briefings. Routine embassy personnel evaluations, State Department communication priorities. Every cable typed in the embassy was logged keystroke by a Hall effect sensor in a Selectric comb support bar. Every daily Hall was transmitted in a sub-second 33 MHz burst to a Soviet apartment 3 blocks away. Every burst was decompressed, transcribed by Russian language analysts at the KGB, and summarized for the Politburo within hours. By 1982, U.S. State Department officials in Washington had begun noticing that Soviet diplomats seemed to anticipate every American negotiating position before U.S. delegations arrived at meetings. The pattern was unmistakable, the leak source was not. The intelligence community ran the standard counterintelligence playbook. Background investigations of all embassy personnel. Polygraph examinations. Compartmentalization audits, cipher machine technical inspections. Radio room sweeps. The standard playbook found nothing because the leak was not in any of the places the playbook examined. The leak was in the structural metal beam underneath the keyboards of 13 IBM Selectric typewriters that had been delivered to the embassy through the standard U.S. Government Services Administration procurement channel, but had been intercepted, modified, and redelivered somewhere in transit by a Soviet active measures team operating against the global GSA office equipment supply chain. The standard playbook had no entry for a hardware implant hidden inside the structural component of an office supply store typewriter. Until April of 1984, when Walter Deeley's hardware disassembly team found the first compromised comb support bar. The strategic damage from the 8-year window is, in retrospect, almost impossible to fully catalog. The SALT II treaty negotiations from 1976 through 1979 ran for the entirety of their critical drafting phase under Soviet visibility. American negotiating positions, internal policy debates between state and defense, congressional consultation summaries, and the personal communications of Ambassador Walter Stoessel and his successor, Ambassador Thomas Watson, Jr., were all available to the Soviet side before each negotiating session. The asymmetry was systematic and sustained. The American response to the December 1979 Soviet invasion of Afghanistan was drafted in the embassy and the State Department in parallel. The Soviet leadership understood the American response posture before the American leadership had finalized it. The same asymmetry held for the Reagan administration's 1983 Strategic Defense Initiative announcement, the 1980 Olympic boycott deliberations, the grain embargo policy debates, and the entire arms control agenda of the early Reagan years. None of this was attributable at the time to the typewriters. Each individual leak was attributed by Western counterintelligence to one of three categories: a human source the Americans had not yet identified, a cryptographic compromise the Americans had not yet diagnosed, or routine intelligence overlap from open-source analysis. None of the categories included structural hardware implant. The category did not exist in American counterintelligence doctrine. The category had to be invented after Walter Deeley's team found the first hollow comb support bar. Walter Deeley signed the Project Gunman Final Forensic Report on June 12, 1984. Within 48 hours, NSA had drafted and transmitted a global cable to every United States diplomatic post worldwide, instructing each embassy and consulate to immediately pack every electric typewriter, every copier, and every piece of office hardware for diplomatic pouch shipment to Fort Meade for inspection. 226 embassies, approximately 3,400 typewriters, 6 months of hardware disassembly work at Fort Meade. The Moscow Selectrics were the only compromised post. The Soviet operation had been geographically targeted. The bugs had been inserted during a specific procurement window in the late 1970s, when a Soviet active measures team had infiltrated the GSA office equipment supply chain at a single warehouse loading dock in West Germany. The same vulnerability had not extended to typewriters delivered to other posts through other channels. But the discovery rewrote NSA technical surveillance doctrine permanently. Before Project Gunman, the standard hardware audit protocol for diplomatic post equipment focused on RF emissions, on power line analysis, on visible component inspection. After Project Gunman, every structural component, every metal beam, every plastic frame, every internal cavity in every piece of office hardware delivered to a high-threat post was required to be X-rayed and verified against the manufacturer baseline specification before deployment. The Selectric bug itself became the founding artifact of modern hardware implant doctrine inside the United States intelligence community. It demonstrated that the most sensitive component of an office machine could be something as boring as a structural support beam. It proved that the standard counterintelligence playbook of the era had a fatal blind spot. It established the technical baseline against which every subsequent hardware implant operation by every adversary intelligence service has been measured. The original bugged comb support bar from the Moscow embassy is now on permanent display in a glass case at the National Cryptologic Museum at Fort Meade. The Hall effect sensor, the memory chip, the burst mode RF transmitter, the antenna wire, the battery pack, the original 80 miniature components that read the keystrokes of 400,000 pages of classified American diplomatic typing for 8 unbroken years. The Soviet supply chain interception operation that delivered the bugs into the GSA procurement pipeline has never been fully reconstructed by Western intelligence. Open source analysis converges on a single warehouse at a forward GSA staging facility in Frankfurt, West Germany, as the most likely interception point. The window is narrow, somewhere between the Selectrics being uncrated for inspection at the warehouse and being reloaded for diplomatic pouch onward transport to Moscow. The interception team had to remove a comb support bar from a Selectric, replace it with the Soviet-manufactured variant, reassemble the Selectric, repackage it inside the original IBM crating, and reseal the diplomatic pouch documentation in a way that survived downstream chain of custody inspection. The technical sophistication of the substitution implies a Soviet active measures team, with access to authentic IBM crating materials, authentic GSA procurement paperwork, and at least one inside source at the Frankfurt staging facility. None of those operational details have been confirmed publicly. The KGB officer responsible for the operation, if any single officer was never identified by Western sources. The Soviet active measures team that performed the substitutions was never rolled up. The Frankfurt warehouse remained in operation as a GSA staging facility through the end of the Cold War. What is documented is the post-gunman procurement reform. After June 1984, every piece of office hardware destined for a high-threat diplomatic post, moved from any supplier to any post, had to be inspected by NSA Technical Services personnel at Fort Meade. Before deployment, the inspection added approximately 90 days to the procurement to deployment timeline. For every typewriter, every copier, every fax machine, every word processor, and eventually every personal computer shipped to embassies in Moscow, Beijing, Hanoi, Havana, and dozens of other adversary territory posts. The cost to the State Department was substantial. The cost of the alternative, an undetected 8-year hardware implant compromise, was, by the Project Gunman record, demonstrably greater. Project Gunman demonstrated a new theorem of intelligence operations that has only become more dangerous in the 40 years since. A hardware implant does not need to be a separate component added to a target machine. A hardware implant can be a structural component of the target machine, manufactured to the same external dimensions and the same external appearance as the baseline part, with the bug packaged inside the structural cavity. A standard counterintelligence sweep looking for added components will not find a structural component that has been replaced by a functionally identical structural component, with extra capabilities packed inside. The added mass, the added thickness, the added complexity, all hidden behind the unchanged exterior of an object, whose presence in the target machine is so structural and so boring that no auditor would ever think to disassemble it. The technique requires only one thing: a point in the target's supply chain where the structural component can be intercepted, modified, and reinserted before delivery. Modern consumer electronics are built from 40 to 60 individual components, arriving at the assembly factory through dozens of separate multi-tier supply chains. Each chain has its own audit trail. The audit trails do not extend, for most components, back to the raw component level. Every modern keyboard, every laptop, every smartphone, every consumer router contains structural elements whose interior cavities are not routinely inspected by anyone outside the manufacturer. The session is logged. The connection is closed. The files remain open. Every keyboard on every desk in every office on this planet is, in principle, a candidate for a modern descendant of the Selectric comb support bar. Every laptop bezel, every smartphone shielding can, every router casing, every printer chassis, every IoT device frame, which leaves us with the closing question of File 18. Which keyboard on your desk right now do you trust the least? To not have a structural component inside it that you have never thought to inspect, silently logging your keystrokes and bursting them home to a foreign capital on a daily schedule.